Hi, my name's Alex, and this is PouchDB Basics in about 20 minutes. We assume that you already have a rough idea of what PouchDB and CouchDB are, and that you have an interest in building offline first or local first software. This video will cover the following topics: storing and loading data locally in browser, updating and deleting data, setting up replication with a remote CouchDB, offline create, read, update, and delete, conflict handling, and powering your UI with the changes feed. Now, if you want to play along, all you need is the pouchdb.com website open in your browser and a bit of JavaScript knowledge. If you want to try the replication feature and conflicts, you'll also need access to a CouchDB. We'll cover that at the very end of this video. All right, let's get going. We won't need to install or clone anything aside from set CouchDB, but in the interest of getting to the fun stuff quickly, we're going to spend zero time setting anything up and demo PouchDB on the pouchdb.com website. So off we go to pouchdb.com. I'm opening the DevTools. I'll make this a bit bigger. It's probably helpful. And it immediately tells you PouchDB itself is hosted at pouchdb.com. To get started, try typing this. So we're just going to do that. DB, new PouchDB, MyDB. We've just instantiated a local in-browser database called MyDB. This constructor is also used to open an existing database. All right, we have a database. Let's put some cute animals into this database. All of the operations in PouchDB generally happen on the database instances. So we just instantiated one called DB. So we're going to use the methods provided by DB. So if we want to make, let's say, a Badger document, we can use the db.put method. All PouchDB CouchDB documents need an _ID field, and with the put method, you need to provide it yourself. These IDs need to be unique, but since we'll only have one Badger, and we already know that, we'll just call it Badger. It's a promise. Okay, so these methods are async, and they also supply a response, so let's check that out and see what we actually get back. Let's put in another animal. For example, this pangolin. Not entirely sure what a pangolin is, if I'm honest, but there we are. Let's see what the response is. The response is, okay, true, ID pangolin. And now this is interesting. There's a new key in here, rev. PouchDB has taken our pangolin document, stored it, and now told us that it has added a revision to it. Revisions consist of two parts. Before the dash, this is an incrementing counter that shows us the how manyth update of this particular document this is. And after the dash is a hash of the actual document revisions content. This is going to be useful later. For now, you need to know that all documents have a revision, and even our Badger. So let's go and get him again. The most straightforward method of getting a document from a PouchDB is actually by its _ID. And since you already know that we have a document called Badger, we can just use the db-get method to get our Badger. Right, let's see what the current Badger now is. Open that up. You can see all the information we put in here is there, but we also have a revision for the Badger. This is also the first version of this document because we haven't done anything to it yet. So yeah, as I said, all documents in Couch or Pouch get a revision. Let's add two more animals, but instead of adding them one by one, we'll add them together using another method exposed by DB, which is bulk docs. Bulk docs simply takes an array of documents instead of a single document. And again, we get a response. Let's check that out. And this looks remarkably similar to what we already saw before, just as an array. Probably what you expected. All right, cool. So how many animals do we have now? Let's use the allDocs method to figure that out. AllDocs takes a bunch of options. The most interesting one, in my opinion, is include docs true. If you don't add this, it will just give you the document IDs, but I would like to actually see all of the documents. And let's see all the animals. Now, this isn't particularly readable, so there's a nice trick you can do here. Instead of logging all animals, like logging the entire response, you can just log the rows. And then ideally, we would also use console table instead of console log. And that is slightly more helpful, but not quite what we need. It would be a lot more helpful if you could see into the doc key, because that contains the actual entire document. So the easy way of doing this is to just map over all of the rows, and for each row, return the doc, and that should look a lot better. Nice. So we can see we have 4 animals. They eat a variety of food. They have a variety of IDs. Brilliant. All right, that covers writing and reading. Now let's do some updating. So maybe we found out that badgers eat more stuff than we previously thought. So let's edit the food value for our badger. Now you would probably assume it goes a little bit like this, where you do another put to the badger ID and just provide a different value for the food key. But PouchDB will yell at you with a 409 conflict error. And will tell you that this is a document update conflict. Boo, what's this? Now, PouchDB won't let us perform this right because it needs to know which revision of the document we're updating. And this is super critical, since revisions are the mechanism by which PouchDB and CouchDB actually power their amazing replication feature and the conflict handling. So let's provide the rev. The easiest way to do this is to take the document we already have. So let's destructure our poor badger. Do another db put, take the current badger that we got previously, destructure it, and then overwrite the food value. Let's see what the response is. Aha, okay, true. And, this is also interesting, the rev changed. We're now at revision 2. And this is the second version of our badger. Brilliant. All right, next up. Let's connect this local PouchDB to a remote CouchDB. Now, in this example, the CouchDB is actually running locally on this machine, but it doesn't have to. It could be running anywhere. And note that for this example, the CouchDB needs to be configured to allow connections from pouchdb.com. And we'll get into how to do that at the end of the video. For now, let's just keep looking at cool features. Now, a brief explanation as to what we're going to do next. CouchDB and PouchDB support multi-primary replication, meaning you can connect several databases via replication and they'll eventually be consistent with each other. They'll all have the same data. You can also do partial or filtered replications as you like, in which case they won't all have exactly the same data, but they'll have the data you want them to have. The big selling point here is that these networks of databases can be partitioned, meaning the individual databases can be disconnected from each other. You'll still be able to use whatever you can reach, and once the connection is re-established, the databases will sort themselves out, and you can rely on the data being eventually consistent. This is a guarantee that CouchDB gives you. And this is really great for offline-capable local-first type applications, since CouchDB and PouchDB are designed from the ground up to work well in this scenario. So in terms of the CAP theorem, Couch and Pouch are AP databases. They're available and partition-tolerant, but not always consistent. And we'll see what that means in practice in a moment. For now, let's set up a replication between this client, PouchDB, and a CouchDB. We're going to do the replication now, and the replication invocation is a bit longer, but we're going to go through it step by step. So first of all, replication is a method on the DB instance again, and in this case it's called sync. Sync is a shorthand for doing bidirectional replication. There is also replicate as a method which is one directional, so either just push or just pull, but we want it to go in both directions, and we want to sync this instance here with this remote CouchDB, where we include the credentials, the host, the port, which is generally 5984 for CouchDB, and the database name. And again, this database needs to exist. Let's briefly check that it does. Over here at Photon, we can see we're in MyDB, and there is nothing in here, so that's great. This replication is also live, meaning that it's ongoing and not a one-off, and retry is true, meaning that it will attempt to reconnect periodically if the network connection goes away. As you can see, the replication emits loads of events you can listen to if you want to monitor things, but that's entirely optional. I've also commented out 2 of them, paused and active, because they tend to get a bit too spammy for a demo like this. Now, let's see what we can do with this. So let's kick this off. And you'll immediately see a bunch of errors. Now, these aren't actually errors, as it says here. This above 404 is completely normal. CouchDB is just checking if a remote checkpoint exists. Everything in a CouchDB is an HTTP endpoint. All the documents, all the databases, all the things you can do to them, everything is invoked via an HTTP request. And when CouchDB wants to figure out whether something exists on a remote CouchDB, it needs to make a request. And if it doesn't exist, it will get back a 404. Hence the red errors and this message here. I'm going to hide the errors just to make this a bit more readable. But all of the errors we're going to get are these 404s anyway, so we don't need to worry about this. Okay, so we can see that the replicator has logged a push, so something has gone in the direction of the CouchDB. Let's take a look at this. We get some information. We see that 4 docs were written, and it was these 4 docs, so probably our 4 docs. And yeah, let's go and take a look at them. So if we refresh this, we should see them. And as we can see, the Badger is at revision 2. The Ferret is also at revision 2 because I secretly did something and didn't record it. Otherwise, everything is exactly as we expect it. Let's take our Weasel and make a change to it, because I do have a slight idea of what weasels eat. Mice. I think weasels eat mice. So let's save that, go back here, and we can see that the replication has logged a pull. Change has arrived, and we can see that our weasel is now at revision 2 and eats mice. Wonderful. Let's stress test this a bit. Let's make 1,000 animals and put them in CouchDB and see how quickly they arrive back at the client. So we're going to use Faker.js to do this. I'm going to hop over here. Faker.js is also very lovely in that you can't really read this due to the background, but it does also let you use Faker in the console. So we're going to do that. We're going to enable it. We are going to make many remote docs. So let's make an array to hold them in. And we're going to use Faker to make a bunch of animals. And I've already prepared a bunch of animal types I wanted to make. Now we're just going to do a for loop 1,000 times and get an animal type from Faker, an animal name, and make some documents. Every document will have an ID, and the ID will be quite deliberately composed to include a lot of information and also to be unique. So one thing we generally like to do is to give each document a type so you can query them easier later on, but also to encode the type in the ID. Makes managing the data a lot easier later on. So this is an animal of a specific type. It has a name, and then it just gets a number. We're also going to give it a fake age and a description, just for fun. That has made a bunch of documents. How do we get those into CouchDB? Well, usefully, the PouchDB library can't only connect to local PouchDBs, but also to remote CouchDBs. So all we need to do this is to pass a CouchDB URL with credentials to the PouchDB constructor. That would look a bit like this. So let's make a remote DB, which is a new PouchDB, which points to the same database that we just started our changes feed, not the changes feed that we started our replication with. All right, let's go back here. Copy our many remote docs into the buffer, hop back over here. And now we can do something like let remote response await remote, DB bulk docs. And then we just paste those 1,000 documents into there. And we get a bunch of replication changes, and you can see they're all pulls. So what's happened now is we've written those 1,000 documents into here. There are now 1,000 documents in the database. And within a matter of about a second, they've all arrived here. That's cool. Let's see how many we have. Let's do an all docs, but without include docs, and see what it tells us about all animals. It should be something like 1,004. Brilliant. Everyone's here. All right, cool. Now let's do the fun stuff. Let's go offline and do some writes. Let's disconnect. Now, if we write our app's code to only ever talk to the local database and not the remote one, everything will just keep working regardless of whether we're online or offline. So let's update our badger's diet again. So we'll fetch our badger and update it again. And this time we're going to say, okay, this badger eats berries and muesli and leaves. So we can obviously read and update. And of course, we can also create new animals. Let's make an otter. And if we look at the response from creating this otter, okay, true. There's our ID, and there's a revision for the new otter. Sweet. And now let's delete the pangolin. I was never completely sure about the pangolin anyway. In a distributed database like ours is now, we can't just completely remove a document, since it would just get replicated back into existence once we reconnect to the other databases that still have a copy of the pangolin. Instead, in CouchDB and PouchDB, documents are just marked as deleted. So the deletion can also be replicated around. So in essence, deletions are just updates as well. So we can delete a record by adding _deleted true to it. So first, let's fetch our pangolin. We put the pangolin back, but we add a key, deleted true. We can see this looks exactly like what we got back from every other put. So CouchDB at this point doesn't really care whether it's a deletion or an edit. It's functionally the same. Where it's functionally not the same is you can't undo this just by setting deleted to false, for example. You also can't go back in time to get an older revision of a document because CouchDB does not work like a version control system where you can rewind any piece of data to any state it's ever been in. CouchDB only guarantees availability of the latest revisions and of conflicting revisions, and everything else will eventually be removed by database compaction, cleanup effectively, to save space. Anyway, our pangolin document is now marked as deleted, and if we try to get it, PouchDB will respond with a 404, just like CouchDB would as well. It says it's missing, and the reason is deleted. So it's actually really cool that we didn't simply delete the document, but actually just marked it as deleted, because now we can also have a reason why it's not there. So under the hood, of course, the deleted document is still flying around in our network of databases, but we don't see it anymore because for us, functionally, it's deleted. CouchDB and PouchDB still need to know about it because otherwise they would replicate it back into existence. But what this means is that we can very easily build apps that can seamlessly work online or offline without the end user having to care much about the connectivity status. And for us as developers, this is very convenient as well, because as long as our code doesn't make any network requests and only talks to the local PouchDB, we don't need to do any extra work to make this possible. The replication features will do all the heavy lifting for us in the background. Let's see that at work. Let's reconnect. And we should see our changes pop up in the CouchDB admin panel. Now, this might take a bit because PouchDB doesn't just, try to clobber the connection and keep trying every second or so. It implements an incremental backoff, which starts at a second and then doubles. The longest incremental backoff it will ever do is 10 minutes. You can also provide your own incremental backoff function. The upshot of this is basically that we needed to wait a bit, but now we can see that the replicator has kicked back in again and has pushed some stuff. And of course, the things we've pushed are our new otter, our deleted pangolin, and our updated badger. We can also check that these are consistent, so we can go over here, see if the otter exists. There's our otter. Fantastic. On to conflicts. Let's do some conflicting offline writes. So we're going to go back offline again with our browser. And we're going to find our badger and change its diet once again. So let's say this badger now also eats ramen noodles. And from the response, we can see that, first of all, this worked, but also PouchDB is very much indifferent to whether we're online or not. It just gives us the exact same response. So that's good. But now we're going to cause the actual conflict. So we're going to go over to the CouchDB, find our badger, and give it a different diet. So let's say that our server-side badger prefers the taste of deep-fried Mars bars. Let's save those changes. And now we're just briefly going to look at what the state of these documents now is. This badger now has a revision of 4-CC86, and our client-side badger has a different revision. It's 4-280D. So reality has now diverged for this badger. This is now Schrödinger's badger. We have two states of him, and it's currently unclear which one is actually reality. Now, inside this browser instance, this is the real badger. Inside the server instance, this is the real badger. So now what happens when we reconnect the two? Right, let's wait for the incremental backoff. Okay, we can see we have a pull and a push, and this makes sense. So first we pull the Mars bar badger from the CouchDB and push the ramen noodle badger from here. Now, what's the state of the document? Let's take a look. We can just refresh. And we can see that the Mars bar badger was picked as a winner, but the ramen badger didn't disappear. The ramen badger now lives in here. There's now a conflict on this document. And we can see, here's the Mars bar badger, here's the ramen badger. Pouch and Couch will deterministically pick the same revision, even if they're not connected to each other. They will always pick the same one as a winner. And in this case, the Mars bar one was selected as a winner. So we're never in a state where a document is in an indeterminate state and the database can't figure out what it should be. It will always pick a winner, but it will never lose the other party to this conflict. So now we could decide here to either delete the other conflicts and keep this one or select the other one as a winner. Regardless of what happens, the conflicts are just kept around for you to decide what to do with. Now, in PouchDB, we can often, when we're getting documents, we can specify the option conflicts true. And with that, we can see which documents have conflicts we might want to deal with. So let's fetch the current badger with conflicts on, and we will see that there's a new key here. There's an array, and it tells us there are conflicts. So again, we have the Mars bar as the canonical version of this badger, but there's also another version we could get. So let's try and get that specific other ramen badger back. Let's call him the conflicting badger. And all we need to do to get him is take this revision number and pass it in as an option to dbget. And this will give us the conflicting badger. This is the ramen noodle badger. Now this is really powerful. With many other local first solutions, quite a lot of your work will involve just getting to this point. And then you're often forced to add a bunch of abstractions in between your sync layer and your actual data, because a lot of other systems can't handle arbitrary data structures natively. With CouchDB and PouchDB, the conflict handling doesn't care about what your documents look like or what data types they contain. There are also no differences between what the data looks like at rest or in flight. Anyway, it's always the same JSON. Let's see how you could easily power your UI with PouchDB. Pouch and Couch both provide an event emitter called a changes feed. This will fire an event whenever a document in the database changes. Now, a bunch of databases have this feature these days, so this might be old news for you. In any case, we can attach a changes listener to our local PouchDB and react to the changes that come in. Then ideally, each change is matched against a decision tree. Does the change affect a document we already have in our UI state? If not, then it's a new document, so we just push it into our reactive UI state and it will appear. If we do know about the document already, we have to check, is it a deletion? If so, we just splice the document out of our UI state and it will disappear. If it's not a deletion, it has to be an edit. And in this case, we replace the document in our UI state. And then that should also update the UI. And that covers all possibilities, really. So even UI updates from user interaction. So if the user changes data, it is written into the local PouchDB. The changes feed event fires. We update the UI state and the UI re-renders. Let's try it out. So let's reinstantiate database, and the changes feed again is also a method you can invoke on the instance. It has a bunch of options. First one being since, so you can specify since when you want to follow the changes feed. So you also can go back in the event order. You could go back to the start. You could go back to a document you already know about. You can start now, which is also a valid value. Live, again, means that it will also emit events for future changes and include docs you already know. That means you'll also get the actual documents themselves. And then in this case, we just log the change. Now, the way I'd like to demonstrate this working is by making the changes in the CouchDB on the server, have them replicate over here into the browser, and then listen to the changes here, which means that we also need to turn on the replication again. So I'm just going to use a version without quite as many events. Off we go. And now we can skip over into here, find ourselves an animal we want to change. Here's a bear called Murphy. Let's make Murphy a lot older. Save the changes. And if we go back over here, we'll see something changed in the DB. And we'll get the changes. First of all, the revision, but since we also had the option include docs true, we also get the entire doc. And we can see, yep, it's a new revision and the age is now 24. And then we can do something with this. So we could, if this bear was currently being displayed, we could update its display. We could send the user a notification that some other user has changed their bear. Whatever we want to do. We don't necessarily have to update the UI immediately. We may not care about the change. You are completely free to handle this however you like. Now let's briefly look at a deletion. Let's find a bear called Bandit. Delete the bear. Poof, bear is gone. I get another change to Bandit. And this time we have an additional key that tells us that this was a deletion and that the document no longer exists. So aside from the fact that the doc has deleted true, this might have already been true earlier for whatever reason. This tells us that the change was actually a deletion in this case and that we can handle it like it was one. That's pretty cool. That covers the changes feed. Next up, we're going to look at querying. Querying is done via a plugin called PatchDB Find. I'm going to import it dynamically here because we're in the browser console. You would import it statically after installing it with NPM or a similar package manager. And what this does is expose a couple of additional methods on DB. So we can now do things like find. If you recall, we added 1,000 animals just now. Let's find a couple of bears. You use DB find and pass in a selector. We're going to use a very simple selector. It's just equality. So we want the field type to be exactly the string bear. And if we fire that off, we get 25 results, which are all bears, reassuringly, but we also get a warning. PatchDB is complaining that no matching index is found. If you've been around databases before, you know that they do like to have indexes before doing queries. Otherwise, they do a very inefficient full table scan and look at every single document to find, in our case, all of the bears, which we do not want. Fortunately, creating an index is really easy. There's now also a createIndex method on DB. This only really requires you to do one thing, which is pass in an array of fields you want to index by. The name is entirely optional, but we always recommend giving indexes a name. It just makes sorting things out later when you're trying to figure out which query is using which index a lot easier. So let's create the index and fire off our query again. And now we can see that the warning has gone. If we did some very precise performance testing, we would probably also see that this is now faster, but with the small number of documents we have, that doesn't really make a big difference. As you can see, we only get back 25 results. This is for pagination, so by default, find will always return 25 results unless you specify otherwise. And just to briefly show you what the pagination looks like, we're going to wrap the whole thing in console table again and use the skip option to skip past the first 25 bears and look at the second set of 25 bears. You'll see we're no longer starting at the beginning of the alphabet, but near C. If we omit skip, you'll see we get A to cookie. And if we skip the first 25, it goes from Cooper to Jack and so on. So that works, but sometimes we do want all of the documents because we know it's going to be a manageable number above 25, in which case we can specify a limit. And if we then unspecify the limit again by setting it to undefined, we get back all of our bears, which are 112. You probably want to make more complicated queries, in which case you'd need slightly more complicated indexes. So for example, let's assume we want to find animals by type and of a certain age. Then we would create an index that indexes those two fields. And that just entails adding more fields to the fields array. Now in Catch and Pouch, it's really important in which order you add fields to an index. I'm not going to go into details on why this is or what you need to know, but rest assured that both the PouchDB and CatchDB documentation go into great detail on this. PouchDB has some really nice approachable examples as well. For now, all you need to know that if we want to find, say, all crocodiles under the age of 10, we need to index first by type and then by age. So let's go and do that. So let's use dbfind to do something slightly more complicated and find the 10 oldest crocodiles under and including the age of 10. So we use dbfind, we have a selector, we already know that we want the type to equal crocodiles, so we don't need a special syntax here because equality is the default. But for less than equals, we need this special operator here, and Mango, which is the name of this query language, has a bunch of these. Also well explained in all of the docs. And here we just say we want the age to be less than equal to 10. And now the other important thing is the sort order. Now the default sort order for find is ascending, but we want it to be descending. So now you would expect that for each field in the selector, you'd need to indicate which direction you want it to sort in. That's not actually how it works under the hood. It only applies the first sort direction to all of the fields. So this is functionally equivalent to this. You only ever need to specify the sort order for the first field in the index. Let's fire that off. And indeed, we get 10 crocodiles under the age of 10, sorted by age, oldest first, which is what we want. If we wanted to have the youngest crocodiles, we could just omit the sort operator because ascending is the default. So let's just do that, and you can see we get the 10 youngest crocodiles. That's all very nice. Once you have multiple indexes, PouchDB and CatchDB will pick the most suitable one for you. But you can always override this. There's a use_index option. Before you start customizing which indexes are being used, you probably want to find out which index is currently being used. And for that, you can simply replace the find with explain. And of course, then remove all of our custom table formatting so you can actually see what's going on. And then it will tell you, okay, we're using this specific index. Since we've given it a name, it's easy to identify. It's by type and then age. If we did the same thing without caring about the age, I would assume it would fall back to the other index. Let's see if that's the case. Yes, now it uses by type. There's a lot more detail to go into here. This is just a small overview that you can, in fact, do nice queries in the client side with PouchDB. For further information, please consult the very expansive docs and also the guides on this topic. All right, wonderful. That concludes our introduction to PouchDB. Thanks for sticking with us for 35 minutes now. There's only one more topic we need to cover. That is if you want to use a local CouchDB to try all of these things out in conjunction with the stuff you're pasting into the PouchDB console. Your local CouchDB needs to be set up in a specific way. This isn't a particularly big thing. You just need to go over here to the settings and configuration, hop on over to CORS. CORS should be on in this case. This is quite useful for local development. And then down here, when you're restricting it to specific domains, you need to add https://pouchdb.com. If this is set, the things you write into the pouchdb.com terminal should be able to talk with your local couch, as shown in this video. All right, that's it. Thanks very much. We hope you enjoy PouchDB and CatchDB. Goodbye.